There we go. All right. All right, so homework again, last homework 6.1, 6.2. Would you guys agree that this is a little bit easier than the chapter 5 stuff? A little bit. Got a little formula. We could do it on the calculator, Z interval and P interval on the calculator. Allows us to get the actual interval between two numbers we think the population mean would be. So quiz number 7. Quiz number 7 is on chapter 6. It sounds deceiving. I usually have a quiz every section, but chapter 5, I typically have 2 quizzes. So instead of me changing the names of the quizzes, I just called it quiz number 7, which is on chapter 6. It's all chapter 6, 6.1 through 6.3, and we haven't even started 6.3 yet. And that's why I didn't make the quiz today. It's kind of hard for me to teach something and be like, hey, all right, let's take a quiz right now. All right, so I want you to do a little practice first, then complete the quiz. You can do the quiz today. You don't have to, though. So that's why I made the quiz due by Friday. Due by Friday, I already published the quiz. You have 2 chances, all multiple choice, 7 questions, but it's worth 15 points. Some of the problems are worth 2 or 3 points. Okay, just because like these are like 1-pointers. Find the Z critical value and the T critical value. That's looking up a number in a table. That's like a 1-point problem. Construct a Z interval. That's like a 2-point problem, right? 3 points, T interval. Find the minimum sample size. So we did a few of these yesterday. Finish off class. Minimum sample size, the N formula. That's what I call it. So that's pretty much everything. There's 7 questions. There's 7 items. That's pretty much your quiz right there. Right? So 7 questions. It goes just like that. Okay. And again, I realized the last 2 items are new. That looks like foreign language, probably. So we're going to cover that material today. So yeah, the last 2 is proportions. We're going to talk about proportions today. In statistics, we always go between means and proportions. So sometimes we're finding the average GPA, the average heart rate, the average cholesterol, blood pressure. Those are means. If we're talking proportions, we're asking yes/no questions. What percent of people, what percent of college students have a tattoo? What percent of college students are community college transfers, right? So we can answer some questions about that at the university level. This is just the Z critical values from the confidence levels. And again, this is straight out of the book. It's in table 5 in the T table at the very bottom. So I was going to answer any questions you might have about those things or about the Z critical value. So the goal is to take the quiz by Friday, take 2 chances on the quiz, at least get some feedback for yourself so you know where you're making your mistake or if you're doing something wrong. And then later on, you can take the test. So the test will be due by Sunday night, 11:59 p.m. So that way, if you have questions, you can always email me. I'll be available. Send me an email if you're confused about anything. But that's kind of the process of where we're at right now. So today we're going 6.3, some notes, and then we're going to do a little homework. I'm going to kind of do this the same way. I'm going to talk about constructing an interval for proportions, and then the minimum sample size for proportions. So that'll be separate. So I'll give you some time, work for about 20 minutes, and then I'll go back and talk about minimum sample size. Any questions or confusion about anything right now? Everyone's good to go? Ready to learn. All right, that's what I like to hear. We're ready to go. All right, so again, 6.3 is population proportions. Whenever you construct a confidence interval for proportions, on the calculator, this calculator input, it's called a 1-prop Z interval. one proportion is the interval. There's two proportions of the intervals, which we'll learn later in chapter 8, but right now it's just one proportion. And we're gonna take one proportion and construct a confidence interval. Proportions are always Z intervals. Doesn't matter how big your sample size is, but if you're gonna go out and collect data from people and you're gonna ask a yes, no question, you should probably have a large sample size. So we're gonna add a couple conditions in order to construct a confidence interval for proportions. So again, 6.3, we are all the way up. We're over halfway done with the course already. July, we're done with the course in July. Confidence interval for population proportions, page 320. And again, just a disclaimer, the book uses one method, kind of confusing. They say, oh, the margin of error is this. So really, when you're doing a confidence interval, you're going to take a value or an estimate and then add and subtract the margin of error. And in the book, we call this E. So your estimate plus or minus your margin of error. Sometimes your estimate is a mean, a sample mean. Sometimes your estimate is a proportion. And then we add and subtract the margin of error. So again, I'm not going to go through the book definition of margin of error. They put an E on there. You can see what margin of error is. Pretty much the Z critical value times. They call this the standard error for a proportion. All of this stuff. But notice that everything is based on your proportion. Okay, everything is based on your proportion. So we have information from people. We can make or get an idea about what's going on in the population. Right. So if I take I'm just going to come up with an example. So let's say I want to know what percent of people, I work for Apple, and I want to know what percent of people have an Apple Watch. Do I need to be more aggressive with my advertising, or is everybody buying an Apple Watch, or how many people are interested in buying an Apple Watch? So if I take a sample, so in my sample, I'm going to get an X and an N value. So N is your sample size. So let's say we ask 100 people. I need a better number. I'm not going to do 100. Let's go 80 people. And 30 of them said, yes, I have an Apple Watch. So 30 out of 80 have an Apple Watch in a population of college students. Okay. Or some kind of watch device, where, have you guys ever seen the cartoon, The Jetsons? Or what was the other movie? Mission Impossible. Oh no, it was Knight Rider. Knight Rider was the show. Guy always talked to his watch and talked to his car. Yeah, anyways, from the 80s. 30 out of 80 is our sample proportion. So that P hat value, P hat is X divided by N. So in this case, P hat is 30 over 80. And we can figure that out, what that decimal would represent. 30 divided by 80. Let's see here, 3 divided by 8 is 0.375. About 37% of college students would have some kind of watch device, okay? Well, given that information, now I can construct a confidence interval. That's all I need is my X and my N value. I only need two things. One of the things we want to do is check the condition. A condition is large sample size. So there's a little calculation for the condition. I'm going to do that real quick. And it should look familiar. This was from binomial distributions. Our sample size, N times P hat, has to be greater than or equal to 5. And N times 1 minus P hat has to be greater than or equal to 5. Some books use 10. It's just, is your sample big enough? For example, if I was going to do this, when I looked around and I was like, I'm going to survey my class and see what proportion have some kind of watch device. I looked out and I only saw a few people that had a device on their wrist. I saw 3 people. Right here, 1, 2, 3. I can see it right now. But the sample size is too small, right? If I'm only going to ask 20 people and 3 people have a iWatch or some kind of watch. What do you call them? Gizmos? I don't know. So 3 out of 20 is a really small sample size. That sample size is too small. Okay. So I would have to get a larger sample size. That's why I came up with this scenario. I have 80 people. So how do we check the conditions? What if I do 80 times 0.375? Guess what number I get? I get 30. How does this work? Multiply both sides by n. X is n times p. Does that make sense? X is n times p. So if I do 80 times 0.375, I get 30. So 30 is bigger than 5. That's a condition check. So these are called conditions. We'll encounter conditions more and more. We had conditions for binomial distributions. We didn't get really in depth with binomial distributions and their conditions, but these are the conditions for a confidence interval for proportions. So 30 is bigger than 5. And then n times 1 minus p is the complement to the 30 out of 80, which is 50. Okay, 50 out of 80 would be the complement. So n times 1 minus p is actually 50, which is bigger than 5. So therefore, my conditions are met. Again, if I had 3 out of 20, that would be much too small. So I need a large sample size. Okay, so condition, check, check. I checked both conditions. I'm ready to construct my confidence interval. The confidence interval relies on this number here, 0.375. So if I got 0.375, I can do the construction of the confidence interval. Again, deviation a little bit from the book, but I'm going to use this formula right here. So plug the numbers in, out comes an interval. There's decimals. Let's see here. 0.375 plus or minus 1.96. Okay, so 0.375 plus or minus 1.96. Where did 1.96 come from? That's your Z critical value. And most of the time, we're going to construct a 95% confidence interval. The book jumps back and forth between 90 and 95. Sometimes it's 99. Those numbers are up here. But that's the most common value. There's p hat. And then I'm going to do 1 minus p hat right over here. 1 minus 0.375 is the complement. 0.375 is this probability of success. 37% of the population have an iWatch gizmo. What percent do not have an iWatch? That's about 0.625. The rest is doing some computations on the calculator. In order to simplify things on the calculator, I tend to just do underneath the square root sign first, multiply by 1.96, get that margin of error. And then at the end, I'm going to add and subtract my values. So I'm going to do 0.375 times 0.625 divided by 80, just in that order. I said multiply and divide all in one motion, press enter. 0.0029. That doesn't sound about right, but it is. That's correct. 0.0029. Hopefully you're following along. This underneath the square root sign. 0.0029. I got a square root now. Don't forget the square root. So I press second x squared, and then second negative. So what my calculator does, it says square root the previous answer. It says square root ANS. So I'm square rooting 0.0029 in my calculator. 0.054. I'm not there yet. This is 0.05. Then I'm going to multiply by 1.96 times 1.96. 0.106. And I did a few computations there with my calculator. If you're uncomfortable doing all those computations, I mean, you could ultimately just put all of this 0.375 plus 1.96 parentheses square root 0.375 parentheses. You could write all that stuff out in your calculator all in one shot if you want to, or you could just write down each step. Okay, do this first 0.0029, then write the next step, then write the next step, and have multiple steps if you're more comfortable with that. Okay, so whatever your comfort level is, I don't want to say this is the right way, but you can do it multiple ways. You can store values. There's the STO button above your on button down on the left. See where it says STO? You can store values like a memory. So all you have to do is press, for example, I had 0.0029. So I just entered 0.0029, press the STO button. And there's a little arrow and then it's flashing. And it's like, what do you want to do with 0.0029? I'm going to store it as a letter. I'm going to press alpha. And right underneath the alpha button is math. Press math. And then press enter. So I just stored 0.0029 as the letter A. There's all 26 letters on the calculator under alpha. So you can store all kinds of different values in alpha. Does that make sense? So it's just like a memory. I just called this letter A. So then you can square root letter A. And that'll give you the 0.054.
How did you get the 0.106? I lost you after 0.054.
So this is underneath the square root sign is 0.0029. Then I square rooted 0.0029.
Yes.
Which is 0.054. So this is 0.054. 0.05 times 1.96. 0.106.
Okay.
Yeah, so you gotta multiply. That's about 2. I knew it was 0.05 times 2. 0.10. About 5% times 2 is 10%. The last step is to add and subtract those two values. 0.375 plus 0.106. 0.375 minus 0.106. Again, the smaller number first. .26. Oh, it's 269. I want to put 0.2. I'm just going to round it to the nearest hundredth of the decimal place. Okay, what are we trying to do here? We're trying to figure out what percent of people have an eye watch. Okay, they got something on their wrist. We took a sample, we found 30 out of 80 have an eye watch. Okay, so that 37% is the sample, but we're trying to make a decision about everybody. So like if I work for Apple, I want to do a survey and find out, do I need to try to sell more iWatches? Do we need to come up with a discount? Because I know I've been looking for one for about a year and they haven't put them on sale yet. I'm waiting for them to come out free or something like that, you know. Hey, you're ready for an upgrade. You know, that hasn't happened yet. They must be doing fine in sales, right? So I mean, if you do a survey, you work for a big company like this, they have a lot of employees. I'm sure I can almost guarantee that's somebody's job, is to ask people, consumers, or maybe they hire an outside company, consumer reports, right? So there's companies that do this research. Gallup poll is one of them. The Associated Press, they have their own researchers, right? They call them researchers. They're really just people just asking people questions, surveying, collecting data, getting information from people to determine what is going on in the population. So again, this is sample data, but what's going on in the population? Well, we're confident, we're 95% confident, between 27% and 48% have an iPhone based on this sample. If I take another sample, I might get different results. I'll probably get slightly different results. Okay. In a survey of 1,000 teens, 372 said they had a smartphone. What percent of teens in the population have a smartphone? That's the question. In a survey of 498 adults, construct a 99% confidence interval for the population proportion of all US adults that think teenagers are dangerous drivers. Okay, so I'm just reading a couple questions out of the book. We're not going to do those questions. I think we have a tool to be able to do this, okay? All right, we're going to check this on our calculator because yes, we can do it on our calculator. We have a Z interval, we have a T interval. This is a interval for proportions. We only have one proportion. There's a 2 proportion, but here's the function right here. So how do you get there? Press stat, go to test. Stat test will allow us to do this on our calculator. And it's a 1 prop Z int, not a 1 prop Z test. Okay, so the tests are the first, you see all this test stuff. That's going to be chapter 7 and 8 stuff. We'll do testing later. Right now we're focusing on intervals. Go down beyond testing and you'll see a 1 prop Z int. Press enter. It's going to ask you for 3 things. This is pretty simple. What is X? What is N? Does it make sense? What is X? What is N? So we just enter 30 and we just enter 80. That's our X and our N. And then our confidence level. We don't even have to enter with a 1.96 in our calculator because it only asks for the C level, the confidence level, 0.95, and then calculate. And we should get a number probably a little bit more accurate than what I have there because I got a little bit of rounding. Pretty close to that, which is correct. They're both correct. Okay, you're going to have slight rounding. Both are correct. The main thing here is when you're given a proportion, when you're talking about percentages, a lot of students confusion here. Some students will just do a Z interval and call like X bar 30 or put 0.375 here and then come up with some kind of interval. So just confusing these two, I think, is the most common mistake that I encountered teaching this. Pretty straightforward. There's sometimes when you don't have a estimate of the population. For example, if I want to know some information about a population, but I don't have any data, I don't have any information, we just assume that about half the population would say yes and half the population would say no. Okay, if you don't have any information about anything, okay? Like what percent of the population choose gum? I don't know. Do I have a survey on that? Am I going to survey you guys now? We'll just say about half. So then I can come up with a confidence interval and say, it's in between these two numbers. So half is 50%. So I would say P hat is 0.5. 0.5, 0.5. And that maximizes your value. Okay. So if you get 50%, that maximizes your value. The same is true when you're looking for the minimum sample size. If you don't have enough information, you would use 0.5 for your P hat when you're constructing the minimum sample size required. Another formula, an N formula. So if we're voting and we just had an election this last month and we're voting for county supervisor, right? And I want to know if I'm a candidate, how many people are going to vote for me? What percent of the population is going to vote for me, right? So I'm going to do a survey. I'm going to ask people, would you vote for me? They probably say yes because they just met me, but I'd have to do a random sample. Okay. If I did a random sample, I would ask the question, who are you going to vote for? Okay. Are you going to vote for me? Yes or no? So that gives me a proportion. So if I ask 100 people, I get a sample proportion. But if I want to target a certain value, if I want a margin of error of about 3%, that's customary for proportions, in elections. Usually when there's elections, it's on the news every single night. It's gonna happen again in November. Who's gonna, governor of California or whatever. It's on the news every night and they show percentages, which candidate is getting the highest percentage of votes. But it always says in the fine print that you never see, there's a margin of error of 3%. Well, now you know what margin of error means. There's a 3% margin of error. So there could be a mistake. For example, in the last election, the margin of error was 3%, when they asked people who you gonna vote for, and it was really, really close, right? Between the two presidential candidates. It was really, really close, but that was only a sample of 1,000 people or 2,000 people. Usually sample size is around 1,000 when you want a margin of error of 3%. Okay, so if I use E as 3%, and my population proportion is 50% of the votes, how many people should we survey? So there's two candidates. There's two candidates usually, it's always Democrat, Republican, and there's other people that get votes, right? So a lot of independents and stuff like that, but most people will vote one way or the other, and we say it's about half. So P hat is about 0.5. So if I go calculate minimum sample size, it's gonna be about 1,000. We want a 95% confidence interval. I'm just plugging in the number. Margin of error is always about 3% margin of error. So we're gonna survey this many people. We're gonna make phone calls. We're gonna call across the country, 50 states. Okay, we're gonna call everyone and see who you're gonna vote for. Most people will just hang up on you. Oh, I'm not taking that call. I think it's a warranty. This one's cool because you can just put it directly in your calculator as it reads. Like I said, it's about 1,000. Hey, there's 50 states. If we have 50 states and I ask 20 people in every state, who are you gonna vote for? Probably get different results from every state, but 20 times 50 is about 1,000. All I need is 50 people to go call 20 people in their state. Yeah, some states are more populous in California. We might sample more people in California than we would in Nevada. Okay, so that's actually how balloting. CNN does a poll. Fox News, they do a poll, and they all have different results, right? I don't know if like I said, I stopped watching the news a long time ago, but I'm familiar with what they do, especially when there's elections. I've been through 6 elections in my life, and every time it's exactly the same thing happens, and they're always arguing about silly stuff. 1,068, that's how many we're gonna sample. Okay, if we're given a proportion, 30% of the population have a iWatch. Okay, 30% of the population have an iWatch. I want a margin of error of 3%. So then I'm gonna put 0.3 and 0.7 here. That'll tell me how many people to sample. So I'm plugging numbers in to that little formula there. Where's that formula come from? It's on page 324. There's a nice little example there. So what I just did, my example is on page 324. So go to page 324, you'll see that. And the 30% and 70%, they did 31 and 69. I was really, really close. So they have 2 examples there. No preliminary estimate is given, use 50%. If it is given, drop that number into the formula so you can see where it comes from. 913.02. Again, we got to round up, 914. And there's a try it yourself there as well. This is one of the shortest sections in the book, 6.3. Proportions, there's only 5 pages, only a couple of examples in there about proportions. I think that's everything you need to know. So I'm gonna let you work on homework, 6.3 homework. It looks like, I'll write it over there. Where we at on 6.3? 12 through 20 even. All right, so 6 o'clock, you work on some problems. Okay, five homework problems from 6.3. So try to get something done, be productive. But I'll leave it up to you. You leave anytime you want to. But that's all my instructions, unless you have questions or anything else. Quiz is due by Friday. Quiz number 7. You can start on that today as well if you want. But you don't have to. You do tomorrow or the next day or whenever you have free time. Shouldn't take more than 45 minutes for that little quiz. Sound good? All right.